Let's set up problem 3b now by taking the reciprocal of that second expression. And so then let's rewrite, we've got 2x squared minus 12x over x plus 5. And we're now multiplying it by x plus 5 over x minus 6. I've got a greatest common factor here of 2x that I can factor out from this very first term in the numerator. When I do that, I'm left with x minus 6. I've got still in the numerator the x plus 5. Moving on to the denominator, there's nothing else I can do to factor these two. So I just rewrite them. And lo and behold, I see that both x minus 6 and x plus 5 appear in both the numerator and the denominator. So my simplified quotient here is just 2x. That's crazy. So let's just take a look-see. I've put in the original function into my graphing calculator. Now, if this simplifies to just 2x, we would expect that that would be a straight line with a slope of 2. So I'm going to hit graph, and that's what we get. That's a straight line with a slope of 2. Now, going back, we are asked to find what values of x make that denominator equal to 0, right? What are the limitations? What are the restrictions on that variable x? Well, if x is negative 5, that makes the first factor in the denominator 0 if x equals 6. That's the second. So there are limit restrictions here that x cannot equal negative 5 or 6. So this is interesting. Let's go back to our graphing calculator and let's look at the table of values here for this. And sure enough, I see that at x equals negative 5, there's an error. All right, that means there's a hole in the graph there. And if I scroll a little bit farther down to x equals 6, there's the other error. So our graphing calculator confirms that we indeed found those two restrictions on the domain of x equals negative 5 and 6. Those are the values that make this function, the equation here, undefined. And those are holes in the graph, which otherwise is a straight line with a slope of 2 going through the origin.